So in this video I will derive the derivation of sin x, cos x and tan x. So these three derivations, which is equal to cos of x, which is equal to sin of x, and this is equal to minus x square x, or tan x is equal to sec square x. So these three derivations I will do using the formula of limit or applying the definition of derivative. So the question is how to do this, and I'll use the formula of cos a minus cos b is equal to 2 of or minus 2 of sin a plus b into sin a minus b divided by 2, and sin a minus sin b is equal to 2 cos of a plus b. So here a plus b is equal to x plus h minus x, and a minus b is equal to h. So if I have d by d of x of sin of x, which is equal to cos of x, so going by the definition, the limit of h tends to 0 is equal to sin of x plus h minus of sin of x divided by h. And now my a is equal to x plus h and my b is equal to x, and sin of a minus sin of b is equal to 2 of cos of a plus b by 2 into sin of a minus b by 2. So what this will give is limit of h tends to 0 is 2 of cos of 2x plus h by 2 into sin of h by 2 divided by h. So if I'm bringing this 2 down, then this will can be written as limit of h tends to 0 is cos of 2x plus h by 2 into sin of h by 2 divided by h by 2, which is equal to cos of 2x by 2, which is equal to cos of x. So this is your answer, or this is how to get a derivation of sin of x using the definition of derivation, applying limits. And the next is d by d of x of cos of x, which is equal to sin of x. So or minus sin of x. So applying the definition f of x, or limit of h tends to 0, f of x is equal to f of x plus h minus f of x divided by h, with limit of h tends to 0 is equal to f dash of x. Now applying the same thing, what you will get is limit of h tends to 0 is cos of x plus h minus cos of x divided by h. So cos a minus cos b is equal to minus of 2 sine of a plus b by 2 into cos of or sine of a minus b by 2, where my a is equal to x plus h and my b is equal to x. So this is equal to limit of h tends to 0 of minus of 2 of sine of 2x plus h by 2 into cos of or into sine of h by 2 divided by h. So this can be simplified. When you will apply the limit, you will get minus sine of x, because this will become 0, or this will become 2x by 2, which is x, and this will be sine of 0 is equal to 1, and this will be again equal to 0. Next is a derivative of tan of x, which is equal to limit of h tends to 0 tan of x plus h minus tan of x divided by h. So your tan of a minus b is equal to tan of a minus tan of b divided by 1 plus tan of a into tan of b. This can be given as, if my a is equal to x plus h and my b is equal to x, then this is equal to tan of x plus h minus of x equal to tan of x plus h minus tan of x is given by 1 plus tan of x plus h into tan of x. So my tan of h into 1 plus tan of x plus h into tan of x the whole thing is equal to my tan of x plus h minus tan of x, which you can substitute here, and this will get limit of h tends to 0 equal to tan of h into limit h tends to 0 of tan of h, which is this part, divided by h into 1 plus tan square uh, x plus h, which is again limit of h tends to 0. So it is seen that this part is equal, it will equate to 1 plus tan square h, or 1 plus tan square x when you will apply the limit, and this part will be equal to 1. So this is multiplied by, and this is 1 into this, and this will be equal to the sec square x. So we will see how this tan of h by h can be equated. So my limit of h tends to 0, tan of h by h, this is a limit in the form of 0 by 0, and this can be equated as limit of h tends to 0 sine of h by cos of h divided by h. So it is equal to limit of h tends to 0 of sine of h by h into 1 upon cos of h. So what is seen is my 1 upon cos of h, this will be again written as limit of h tends to 0 of sine of h by h into limit of h tends to 0 of 1 upon cos of h. So 1 upon cos of 0 is 1, so this will equate to 1. So you will be left with limit of h tends to 0 sine of h upon h, and this is valid in an interval of, and if you are saying for values as your limit is approaching 0, it will approach 0 from the side of -1 and it will approach 0 from the side of +1. If you are taking the limit of sine of 0 very, or sine of h in the range when it is approaching to 0 from both the sides, so what you will see is a graph which can be set as to, suppose if you are taking a value of h equal to 0.7 minus, so this will be equal to sine of 0.7 divided by 0.7 minus. So sine of sine of minus 0.7 is equal to minus 0.0122 and divided by minus 0.7. So this is equal to somewhere close to 0.017. So if you are taking multiple values, what you will see is that as your x is approaching 0, the function will have a value which is close to, this is my f of x and equal to y, and this is my x. So as my x is approaching 0, your y will be close to 1, or it will converge across 1. So this kind of behavior is seen, and it can be assumed that your sine of h divided by h will be equal to 1. So this whole equation or the limit can be assumed approximately equal to 1 in this case, and that's how you are saying that it is equal to 1 when it is approaching close to 0. Limit is approaching close to 0, but the value of h is not equal to 0. In such case, the limit of h tends to 0, tan of h by h, or specifically the sine of h by h will be equal to 1. It is approaching close to 0, but it is not equal to 0. In such cases, you can take the limit equal to 1, and that's how you will get the answer or differentiation as of d by dx of tan of x is equal to sec square x. The same thing is valid if you are taking the limit of h tends to 0 for sine of h by 2. So in this case, it is approaching, h is approaching close to 0, but h is not equal to 0. In such cases, this can be equal to 1, which is again used for a derivation of d by dx of sine of x is equal to cos of x, and d by dx of cos of x is equal to minus sine of x. So I just took a value of h is equal to 0, 1, and to get the exact curve, it is possible to take multiple values like minus 0.08, minus 0. And so on, until you are getting a curve which will validate the assumption that it will converge close to equal to 1 at a time. So the graph, if you plot the graph exactly, it will be something like this, as the value will approach, this is minus x plus x, and this is y is equal to f of x, while my f of x is equal to sine of x by x, and my x is tending to 0 while x is not equal to 0. So the graph will be moving close to 0 and it will move around 0. So you are not considering a case where it is equal to 0, but in the vicinity, as it is approaching close to 0, it will be equal to 1 here.